Hello everyone, welcome to the Connected Tech channel where you'll find amazing videos regarding software tutorials, simulation, downloading and much more. So please like and share this video and subscribe to our channel. Thank you so much. I'm Sandesh, here to take you through the steps involved in the CAM, the computer-aided manufacturing software called MasterCam. It's open here. We'll take you to the steps. And then I've chosen a model, the turning model. This is just a simple cylinder which is turned at various places, and there's a thread, as you can observe here. That all dimensions written here below these are in mm, the millimeter. All dimensions are in mm. As you can see, this is standard used. So these are the lengths of the turning object, the turning model, if I can say specifically. These are the lengths of the model, and these are the diameters of the model. And let's get started with the MasterCam. Let's open the MasterCam here. So this is the MasterCam, as you can see here. To get the MasterCam software, we have another video how to download the MasterCam and use it. So let's get started with all these options here in the ribbon bar. This is the file where you can see the new, merge, pattern, import directory, and edit. This is used after when you start the modeling, and view and analyze the properties here and create. You can use this to create points, lines, arcs, fillet, chamfer, and all these things which you can find in the quick links here below. These are the quick links here. Here to activate the work coordinate system axis, that is the WCS, we're in the top plane, and the coordinate plane is the top plane, and the geometric view is the top plane. Geometric view, work coordinate system, and coordinate plane are all at the top. So to activate the reference plane, we're gonna press F9 key on your keyboard. F9, you get the reference plane here. You can activate it. So to start that, we're gonna save the file first to our reference. We're gonna save the file first. So I'm gonna save my file. So we'll start at the center point. You should see an icon like this. So I'll click on the icon, and then I'll drag the line and just click anywhere else on the straight line of the screen. You should get a straight line 90 degrees. So here it's already 16.29. I just have to type in 16.25 from your keyboard, the number pad, and then hit enter key on your keyboard. That makes half of this part, that is 32.5, 16.25. So I have to travel all the way across here and then come down. That will be taught in a few seconds. So again, I'll click on the line, come at a distance. We'll check the distance, that is 40. So I'll just type in 40 mm, and that'll be typed back. So if you want to arrange the screen, just scroll your scroll button in a mouse, roll it backwards and forward, back and forward. So then hold the Alt key and then your scroll button to move it across the screen. You should hold the Alt key and your scroll button all together to move it along the screen. And then you can zoom out by rolling back the scroll button. And then we're going to the next step, that is this point. As you can see here, there's a drop down here. As there's a difference between 32.5 and 20, that is 16.25 and 10. So we gotta subtract that. I'll take a line. Just pull it down to any distance. This is irrelevant, irrespective of all the dimensions here. Just pull it down. Then we can edit the line section here. It was 16.25 minus half of 20 is 10. So I'll just hit enter. That is 6.25, 270 degrees. That comes down. Then I have to travel 20 to my left. That remains same. So I'll hit here, go to a certain distance, and I'll hit 20. Then the next section I have to create is this point here, which is 20 and 30, that is 15 minus 20 upwards. So I'll just click here and go up. 15 minus 20, or 15 minus 10, I'm sorry, half of 20 is 10. So I'll hit enter. That'll be 5. The horizontal distances remain same, that is 30. I'll hit here, click and drag and hit 30. And then again we gotta go up here that is 30 and 35. 35 half is 17.5 and 15. So again, I'm gonna click here and go a little up. I'm gonna hit 17.5 minus 15, that's 2.5, and then the horizontal distances remain same. This is 30 here. I'm gonna hit here and then 30 on my keyboard. Zoom out a little bit and then come back to the diagram. So we completed 1, 2, 3 and 4 parts of the turning model we have chosen here. Then we're going to the bigger step, that is 50 and 35. Half of 50 is 25 minus 17.5 to the upper direction here. So that'll complete the bigger part of our model. So I'm gonna click here and move up. I'm gonna type in 25 minus 17.5 on my keyboard and hit enter key on my keyboard. The horizontal distances remain same, that is 40. I'll type in 40 and hit enter on my keyboard, and I'm gonna zoom out a little bit and hold alt and scroll button to move and arrange it in the direction or the space you wanna keep the files in. And then we're coming to the bottom section here, that is 40 diameter, 40 and 25. We completed with this huge one, and then we're coming down. So that is 25 minus 20. We're coming down, remember that direction, coming down, that is 25 minus 20, that is 5 mm, and then the horizontal distance remains same, that's 25, and then I'm gonna go 25 across here, and then the final part is 50 and 40 up direction, that is 25 minus 20, that becomes my 5. Here I'll hit the 40 and then another step. Don't close the model here. I hit 40 and enter on my keyboard. Here in this turning, as if you know about the lathe operations, the lathe has a chuck, so it has to have a space to hold the material. So we'll create the material to hold for the chuck here. So I'm gonna just go a random number 10. You can give any amount you like, and then I'm gonna go 20 on a random scale. This portion is for the chuck to hold in. You'll get to know later, and I'm gonna pull it down for any distance, and then here you have a trim option. Remember to press this divide, and then click, and that'll be cleared, and then okay. Save it here, and now and then you gotta save it. Then alt click and arrange this in the center position. This is my comfortable way. And then here comes the starting of the model, the turning operation, the steps involved in the MasterCam operation. I'm gonna go to machine type. We're not gonna mill it, we're gonna lathe it. Lathe and default. Default lathes are the generic conventional lathes used. You can use any lathe here, even till the advanced CNC. So I'm gonna go to default. I'm gonna use a generic lathe, that is a conventional lathe. So it automatically clips in to the front end of the model, because the chuck always sits here. It is the mirror of the direction. If it is to your right, it will be to your left. So I'm gonna place it in the middle, just like that. Zoom out and place it in the center. As you all know, this part will catch the chuck. So I'm gonna drop down the properties here, stock setup. Remember the steps carefully. You can write it down in a book or a sheet. So we're using a left spindle for the stock. So here should be our stock. This is irrespective, it is how you create a model. Then click on the parameters button here, and then easy is to give the OD, the outer diameter. If you have an inner diameter, you can give inner diameter. This is changing for each model, because this one is an easy one. It has a smaller diameter and a bigger diameter range, so I can make it from 2 points. So make from 2 points. I'm gonna click from here and then all the way here till the chuck point. So this creates the full object by the software itself. So this is the important part. Then base Z, the base Z you can call it also. on the right face. You can give the stock on the left face. If the chuck is on the right, you have to give a stock to the left. If the chuck is on the left, you have to give stock to the right. So I have a chuck on the left, so I'm giving the extra material on the right face to face the object. Then for base, I'm gonna give a random count of 5. So remember that this 5 offsets the selection 5 mm forward. So this selection will come forward just like that. You don't want that to happen. So go back to the parameters button and then add 5 to the length. So 245 plus 5 makes you 250, and then hit OK. Then that'll be arranged in a good way. Then pull this up, and then you have to set a chuck for this parameters. Then nothing should be changed here. These are all depends on the machine or the model you choose. It is according to the depth of your knowledge. So one thing should be changed here is the position. From stock, you have to give a grip length. Don't click anything, just give a grip length. As I had given 20 here, I'm gonna give 10 to get it to the half of the part, and I'll hit OK. So it came to the half section. I don't need a tailstock because I have a stock here to face it, and I'll hit OK. Save it once again, and now you have a section here already. It's been ready by the chuck and then turning experiment. It is ready. The first thing we have to do first and foremost is to face the edge. Why this is important is you should get a smooth surface because you have given an extra material. The surface should be even. So we go to toolpaths and lathe face. You can select here, or you can come here, right click on your mouse, right click, lathe toolpaths and face. So if you want to remember the icons, you can select from here. The icons are here. So I'm going to select lathe face toolpath. You got to select a facing tool, rough face right 80 degrees, rough face right 80. Remember this selection, or you can OD finish right. This is for the smooth finish, or you can select OD rough right. Anything is okay. Face parameters, nothing to be changed here, and I'll hit OK. Then this is faced. The first operation is done. Next, what we're gonna do is we have to roughly remove this surface along the profile. This removes roughly the profile which we want to know, which we want to see the final product. This is like roughing. So I'll hit the right click here, lathe toolpaths and rough, or I'm gonna come here in the toolpaths, I'm gonna click rough. This let it be whatever the default selection here, because the chain will help will make you select the whole chain, but we don't want that. We want only the profile because we have an extra material left for the chuck. So I'm gonna keep it partial and the alignment inside. So what I'm gonna do is I'm gonna hit OK here, but before that I'm gonna select from here this part, because from there the tool moves in the rapid movement. I'm gonna click here. You're gonna observe that the green is this profile selected and the red is the tool movement. Remember that red is a tool movement and green is the profile selected. You should note down that the profile selected should be started from here and the tool should be ended here. This assures you that you have selected the right profile. Then I'll hit OK. You gotta select the right tool, so let it be by the default. It has been selected here. Rough parameters, so stock to leave in X and stock to leave in Z, that is the front and the upper region. This I'm gonna hit a random 1 mm. Why? Because we're doing a rough finish, so we don't have a smooth finish. This rough parameters, if you leave 1 mm, it'll be helpful for the finish operation. And then I'll hit OK. So you can see the simulation already. So this is just a rough surface finish. We need even smoother, so I'm gonna finish this with a smooth finish. I'm gonna click the finish and the same profile should be selected. The tool path should end here, and then hit OK. So you cannot rough it, you have to finish it. So remember to change the tool for every operation. You gotta make sure the tool is changed. None of these is relevant for us, so I'm just gonna watch over the tool. This is default set by the software. This is the OD finish, right? That for the finish operation. Then finish parameters, nothing to leave in stock because that's the finishing we have to do. Then I'll hit OK. This is finished neatly, as you can see here. Then what are we left with is the groove here and then here. You cannot rough it or you cannot finish it. You have a grooving tool. If you worked on the lathe, you know about the grooving tool. So lathe and groove. I right click, lathe toolpaths and groove. So 1 point is for the tool which is rapidly moving in, or a curved surface what you have, that is 1 point. 2 points is when you have an axis or a thread points here. 3 points or 3 lines is for intricate shapes. Now groove definition, we're gonna give a chain. So we want our tool to come in and move out of the chain. So here you cannot select, so you have to give OK, and after giving OK, let it be partial. Now I'm going to select, zoom in a little bit. I'm going to select this portion and then this portion because I want my tool to come in and face this or groove this area and remove this area too. I don't want this to be removed. If this is selected, the whole portion of these will be removed, so I don't want that to happen. I'm gonna make sure that I'm clicking here, because if I click here, as you can see, the green arrow and the red arrow will coincide. I don't want that to happen. I want it here. The toolpath arrow should be here. So the profile arrow comes here and the toolpath arrow goes out. I'm gonna hit OK. So let it be the groove center, or you can select a groove left narrow because this is easy for me to groove. And then group shape parameters, nothing to be changed here. Make sure that the angle is 90 degrees clockwise. And then rough parameters, this is a bidirectional. Bidirectional is used when you have only grooves, because we don't have only grooves in this profile. We have cut sections and all the different sections here. We don't have only grooves, so I'm gonna give chain direction. Remember this, cut direction, change it to chain direction. You can give a smooth finish or a steps finish. So for smooth finish, you have parameters here, the steps to remove, the sweep angle, everything. You gotta make sure you give the right ones. Make it let it be default, so nothing to be changed here. And when you come to feed rate, we don't want rapid movement here. Grooving should be slow and steady, so I'll give 1 mm per revolution. And then groove finish parameters, this will be automatically selected, so nothing to change in retraction moves. And percentage of tool width, let it be the same, and I'll hit OK. So this is finished now. The grooving is done here. So the same way I'm gonna groove it here. So lathe plunge rough, that is irrespective. So lathe toolpaths and lathe groove. So I'm gonna groove the same way, as you can see, the chain command, then OK, and select the same way here, this path and then this path. So the arrows, make sure the arrows are in the same direction, then I'll hit OK. Now you can select the left or you can select the center. Why I have selected center is that the tool has to come from that retraction point till here and then groove it. So if you select the left, it won't do it properly because it's based on the experience if you worked on the lathe. Then groove rough parameters, chain direction, then I'll hit smooth. The parameters remains the same, 0.2, 45 and 2. And then groove finish parameters also, you see I've not given the feed rate here, so it won't take the feed rate here. So I'm gonna give feed rate here as 1 mm per revolution. And groove finish parameters, let it be the same for all the options. Then I'll hit OK. Don't worry about the extra material removed here. This is for the tool to get entry into that, and the dimensions won't be removed after this. So then all the operations are done, but we're left with the metric thread. How to put a metric thread here of 0.8 mm? It's easy. I'll hit lathe toolpaths and lathe thread here, the third option. And then here you gotta concentrate on the tools. This is the OD thread, right? Okay, the tool, but you have to right click on this, not the left click, the right side click of your mouse, and then edit tool, and then you have a metric thread here. So I'm gonna be selecting metric 60. This is the outer diameter thread, so I'm gonna give the OD, not the ID. Remember that selection. The holders and parameters, the straight shank, this is by default it's selected, the parameters remain the same. And then I'll hit OK. So travel through these tabs to make the certain changes, so it'll change by automatic. Then I'll hit OK. Thread shape parameters, this is the main section you gotta concentrate on. I'll hit select from table. This is by the design calculations, the basic designs, how you calculate the thread dimensions by the design formulas you have. So this decides based on the design formulas. So we don't have the formula here, we just have the ready-made pitch 0.8 mm for the 32.5 diameter. Remember, 0.8 mm pitch for the 32.5 diameter part. This comes to use in compute from formula. So MasterCam has a formula built in by itself for all these general thread dimensions, the standard ones. So I'm gonna click the metric M profile. Lead is 0.8, lead is the pitch. Basic major diameter is 32.5. As you can see, the formula result is here. It'll change as you press the enter. So it's been changed here for minor diameter, and I'll hit OK. So make sure that the start position and the end position are given right. So the start position is 0, absolutely. The end position is for the full length of this part, that is 40 mm. So as you can see, the minus is the opposite direction of the x-axis. Here is the first quadrant that you can see the plus axis for the x-axis, and then in the second quadrant and the third quadrant you will find the minus sign for the x-axis. So end position, you can select it from here, or you can just enter there manually, minus 40. You can enter manually here, minus 40. So thread cut parameters, nothing to be changed here. You can change the lead-in angle, finish pass allowance, and acceleration clearance by for the middle threads or the intricate or the complex threads you want. You can change it here, or otherwise you can remain as it is, unchanged. I'll hit OK. That the threading is done, and I'll zoom out. I'll check if all the operations are done. How? You have select all operations button here and regenerate all icon here. Just click on that. So all the operations are regenerated once again. This will ensure you that all the operations are done clearly. So then you gotta select all again, and then this is verify the selected operations. The solid icon here, this verifies the operations done. This is in the front view now. You can change the views here to front and top and side and isometric. Then I'm gonna pull this up a little bit. I'm going to reduce the speed. This is the speed of the operation. You can stop after each operation. For the illustration, I'm going to click this. This is not necessary for you while working in a faster mode. I'll hit the play button. Facing is done. As you can see, the evenness of the machine, and the roughing is done now. As you can see, the tool label is given here and the tool path is given here. So roughing is done, and now finishing is done. And then now grooving will be done. The plunge rough, tool path 20, groove left, and I'm going to increase a little bit speed. That is done. And then another groove is done. And then we're left with the thread. Threading is done. So threading seems to be odd or awkward from this direction. I'm going to show it to you in a better way. If you zoom in, the thread will be the exact way you'll find it on the machine. So that's it. So these are the steps, and then don't forget to hit OK. So and then save. If you want to get a G code or M code, this is a post processing. You can, this is an NC file, numerical code file. NC is numerical code. then it'll ask you to overwrite or send to machine. You can send to machine to the communications panel. We're not sending into machine, we're just viewing the G code and M code, and hit OK. If and only if you have saved your file here, it will appear. If you have not saved your file, it won't appear, or the numerical code won't display. I'm gonna hit save as I have saved my file. It asks, yes, I have created that for practice, and I'll hit yes. So this is the completion of a numerical code. This is the advantage of a computer-aided machining software, because it creates the codes on its own. As you can see, the C and C codes are created. You can change the codes as accordingly. If you don't want, you can just save it and then post it to the machine which you want. So all the codes of 283 lines or blocks has been created. I'm just gonna save it and then close it, and then save it once again. And yes, these are the steps which are simple yet fun while working in the software. You can download the model in a PDF format, which the link is in the description. And thank you for watching. And to download this software, we have a link and another video. Search for our channel. But before that, like this video, share this video, and subscribe to our channel. Thank you for watching till the end. Have fun and have a great day.